When a generative AI answers your question, it doesn't just rank links, it selects sources, synthesizes them, and often satisfies your curiosity before you've clicked anything. So the question for anyone publishing online has shifted. It's no longer just about appearing in a list. It's about whether your content actually shapes the answer. This paper, by Zhang Kai and colleagues, introduces a rigorous measurement framework for exactly that challenge, called Generative Engine Optimization. Classical search engine optimization was built around ranked lists and click-through rates. But generative engines like ChatGPT, Google AI Overview, and Perplexity have changed the game. They retrieve sources, write a synthesized answer, and attach citations, often satisfying users entirely within the interface. This means a source can appear in a citation list as a weak footnote, while a different source supplies the actual definitions, numbers, and reasoning that build the answer. Those are very different outcomes, and they need to be measured differently. The framework proposed here breaks the problem into two stages. The first is citation selection, whether a platform even triggers a search and chooses your page as a source. The second is citation absorption, whether your page's language, evidence, and structure actually flow into the generated answer. On screen, you can see this pipeline. A prompt enters, the engine searches and selects sources, then those sources are absorbed to varying degrees into the final response. Understanding both stages is essential. The study analyzes the public Geocitation Lab dataset, a carefully designed research object covering 602 controlled prompts run across 3 platforms. It contains over 21,000 valid search layer citations, nearly 24,000 citation-level feature records, and 18,151 successfully fetched pages, each characterized across 72 features. Prompts were organized into 4 layers: a main experimental layer, a style contrast layer, a language contrast layer comparing Chinese and English, and a layer of realistic and extreme scenarios. Before diving into results, let's look at how selection is measured. For each prompt and platform, the researchers ask, did search get triggered at all? And how many citations were produced? You can see the 2 defining equations on screen. The first is simply a yes or no indicator of whether search fired. The second counts all valid citations under that prompt and platform. Together, these define citation breadth, and critically, breadth is not the same as depth of use. Absorption is measured by an influence score, shown here. It rewards a source for being referenced multiple times, appearing early in the answer, covering more paragraphs, having high TF-IDF similarity to the answer text, and strong n-gram overlap. Each component gets a weighted contribution. This score is an observational proxy, not a direct window into the model's internals, but it connects visible page content to visible anchor text in a principled, reproducible way. Now let's look at the headline finding on citation breadth. Search triggering is essentially universal. All 3 platforms fire a search for nearly every prompt, but the number of sources cited differs dramatically. Perplexity averages over 16 citations per prompt, Google averages 12, and ChatGPT averages fewer than 7. A naive reading might conclude that Perplexity is the best platform to target because it cites more sources. That conclusion, as you're about to see, would be seriously mistaken. Here's the core empirical surprise of the paper. When you look at absorption rather than breadth, the picture reverses. Among fetched pages, ChatGPT's mean influence score is 0.27, substantially higher than Google at 0.06 and Perplexity at 0.06. ChatGPT cites far fewer sources but uses the ones it cites far more deeply. Perplexity casts the widest net but dilutes influence across many sources. This is what the authors call the breadth-depth divergence, and it fundamentally changes how you should think about geostrategy. Who gets selected in the first place? Looking at source type composition, official, news, and vertical sources dominate the citation pools, accounting for roughly 80 to 88% of citations depending on the platform. High-frequency domains include YouTube, Wikipedia, Reddit, Reuters, and LinkedIn. But here's the key insight from the data. Being selected often does not mean being deeply absorbed. The domain that appears most frequently in the selection pool is not necessarily the one that most powerfully shapes the generated answer. What predicts whether a page gets deeply absorbed? The structural evidence is striking. High influence pages, those in the top quartile of the absorption score, have more than 11 times the word count of bottom quartile pages. They have 12 and a half times as many headings, nearly 9 times the list density, and more than double the semantic similarity to the generated answer. High influence pages are not just longer, they are more modular, better organized, and more semantically aligned with what the answer actually needs to say. The word count trend shows monotonic improvement in mean influence as pages get longer, up to about 3,000 words, where there's a modest plateau. But the authors are careful to note this is not a simple rule that longer always wins. Length only helps when it comes with usable structure, semantic alignment, and evidence density. A long page full of boilerplate or repeated navigation menus will not score well. The value is in organized, extractable content, not raw volume. Looking at independent feature correlations, the strongest predictor of absorption is LLM-rated relevance, with a correlation of 0.43. This is followed by answer to citation embedding similarity at 0.36, LLM content quality at 0.29, and question to citation embedding similarity at 0.25. Semantic fit is a stronger signal than any single structural marker. The generative engine appears to preferentially draw from pages that are topically and linguistically close to what it's trying to say. Now, here is one of the most practically important findings, and a counterintuitive one. Many geo-guides recommend converting content into FAQ or question and answer format, but the data shows Q&A formatted pages have slightly lower mean influence than non-Q&A pages. Meanwhile, pages containing code, numerical statistics, definitions, comparisons, or how-to content show dramatically higher absorption, up to 77% higher for code-containing pages. The lesson is clear. Evidence density matters far more than surface formatting. The semantic role a citation plays also matters greatly. Pages assigned the role of definition or comparison in the answer have mean influence scores around 0.15. Pages used only as background references average around 0.08, and pure reference citations drop below 0.06. This confirms the absorption concept directly. A source gains answer-level importance when it supplies the specific type of information the answer requires, not just by being present in the citation list. Platform behavior also differs at the feature level. ChatGPT's strongest absorption signal is LLM-rated relevance. Google's strongest signals are embedding-based semantic similarities and the presence of definition markers. Perplexity combines relevance with heading count and page length. These are platform-specific descriptive profiles, not permanent laws. But they reinforce the finding that a single universal optimization recipe will not work across all generative engines simultaneously. Across question types, comparison questions show the highest mean influence, followed by definitional and how-to questions. By industry, technology has the highest average influence, followed by healthcare and commerce. These patterns make intuitive sense. Comparison and definition questions demand structured, evidence-rich answers, exactly the kind of content that high absorption pages provide. This suggests that content designed around comparison frameworks and clear definitions is particularly well suited for deep citation absorption. All of these findings support what the authors call the evidence container hypothesis. A page becomes valuable to a generative engine when it can be decomposed into reusable, semantically aligned information units. That means clear topical scope, section headings that mirror user subquestions, paragraphs each carrying a distinct claim, and extractable evidence like definitions, statistics, comparisons, and step-by-step procedures. The gateway into the citation pool still requires authority and indexability. But once selected, absorption depends on semantic alignment and usable evidence structure. The paper is careful to separate what the data can and cannot support. Direct counts and platform-level descriptive contrasts are treated as empirical findings. The evidence container mechanism is presented as a plausible interpretation consistent with multiple converging patterns. Causal claims, for example, that adding a comparison section will definitely increase future absorption, are reserved for future controlled experiments where page features are manipulated and outcomes are remeasured. This scientific discipline is central to the paper's value. So what does this mean in practice? For getting selected, focus on credibility, fetchability, and metadata alignment with likely query intent. For getting absorbed, Write pages as modular evidence containers. Use headings to expose your semantic skeleton, include definitions, numerical facts, comparison tables, and procedural steps. For evaluation, track both citation occurrence and answer-level influence separately. A dashboard that counts citations alone will miss the central pattern of this dataset. Breadth and depth diverge, and both matter for different objectives. To summarize, this paper introduces a two-stage measurement framework for generative engine optimization, separating citation selection from citation absorption. The key finding is a sharp divergence. ChatGPT cites fewer sources but uses them far more deeply, while Perplexity cites broadly with lower per-source influence. High absorption pages are longer, more modular, more semantically aligned, and packed with extractable evidence. Q&A formatting alone doesn't help. The evidence container model explains why. Future work should test these patterns through controlled page rewrites and longitudinal platform monitoring.